Welcome to my talk titled Build to Hack, Hack to Build, or Hack to Build, Build to Hack. I confuse the two quite often. So who am I? My name is Chris Leroy. I'm a security engineer at Heroku. You can find me on the internet at Brompony. If you want the backstory behind that handle, feel free to throw something at me and ask. I like hacking stuff, and I'm particularly lazy in such a way that I like to build stuff that makes me hack stuff a little bit quicker. So I've built a couple of things to hack web, Windows, Android, and now containers. So this slide's more for me than it is for you, so I don't forget what it is that I've got to share with you today. But of course, there was a problem. We're going to look at some existing research. Then I'm going to introduce Bob with a silent T. Then we'll look at some capabilities and integration, and of course a conclusion. So that's just a rough outline. So, what are the problems or problem? So, I work in a very modern cloud DevOps, SDLC, agile environment. No machine learning yet, but one of the issues that I often ran into was how do we identify and exploit container vulnerabilities, which is quite a common problem, whether you're a pen tester or an engineer. But after dealing with engineers quite a lot, I ran into that last point, which is kind of the same problem but slightly different. And once you're popping containers and identifying vulnerabilities in containers, in a large-scale environment, how do you test, secure, and monitor? And when you're doing rapid deployments, when you're doing thousands of deployments a day with a lot of containers and a lot of things that can go wrong, it becomes a little bit more interesting and a little bit more than just popping shells and getting root on a box. So with that problem in hand, and particularly looking at popping containers, this is some existing categories of tools out there that I found quite useful. This is a partial list. This is by no means, definitely not all the tools available. But when you're on a container, one of the first things you do, especially if you're a pen tester, is you run ammo contained, because depending on the syscalls and the Linux capabilities that are available in that container, that will dictate what you can do in that container. And ammo contained will tell you that. So one of the first things you're going to do when you want to break out of a container. Then there's Google Container Tools. One of my favorite tools at the moment is the Container Structure Test. Really great way to statically analyze an image and work with the tar layers. You can also work with the container as well, but there's a whole bunch of other tools in that repo that are actually really useful. Then there's Claire, which is one of the more older, but more, it's been around longer than a lot of others in terms of vulnerability analysis and containers. So static analysis containers, your container may have vulnerability X in it. Then there's Aqua Security, who's actually released a lot of other tools as well, but there's this one particular category. So there's the Docker benchmark, which is quite useful in an environment when you want to benchmark your containers from a security perspective, and that actually is quite useful. So these were the categories of tools that I found existed that I could use from a pen testing background and from an engineering background. And this research deserves its own slide, and this was actually released at B-Sides Barcelona. And this was released by a researcher called Elena Radu. I apologize if I'm pronouncing their name wrong. Please correct me. But this was really cool because while I was doing this research, I saw this talk, and this was one of the first pieces of heavily directed towards CI/CD pipeline technology and containers. So it's not something that if you're in a container, it's not a binary that you just drop on the host, but it is a framework targeted towards your CI/CD environment, and it's very, very cool in terms of that. So I really recommend having a look at that. And I saw this and I saw, well, this is really great if you have an existing SDLC and CI/CD that can support this framework. So it can be done. So how do I like to solve problems? So I'm not an engineer, I'm not a dev, I just break shit, I break stuff, sorry. This talk's recorded, so I should probably curse less. But I like to break stuff. And to do this, I created something called BreakAfterBox, or Bob with a silent T. I have a very bad reputation for tool names, so it may change in the future. But anyway, written in Go, because I just wanted to embrace the inner hipster in East London. And it's released as a binary, so it's not a framework. It's a binary that if you're on a host, you want to execute. Like I said, I'm quite lazy, so when I'm in a host, I want to autopwn stuff. Of course, I want to understand what it is that I'm running. But I wrote something that's going to allow me to autopwn common container vulnerabilities, because after you get the 10th shell on a container, you kind of get bored of running the same commands over and over. It also helps me to perform common container recon functions. So think Linux post-exploitation, but there are a lot of quirks in containers that you'll find along the way, and I'll discuss some of those. And also, in terms of these capabilities, I implemented them so that you can perform them in a way that's useful for engineers and pen testers. So not about popping shells, of course, it's there for that, but also in a way that you can use it with engineers and in CI/CD environments. And I'll show you how I actually went about that. And I did make the GitHub repo publicly available this morning. You can find it there. Remember Bob with the silent T, but T is in the URL. And there's a lot of examples and all over there. So first thing we're going to do, let's just pwn all the things. And if you're pwning Docker containers, Docker.sock is the first thing you're going to do. What is Docker.sock? It's a Unix domain socket using Unix systems for inter-process communication. It is pretty much the core thing when it comes to running Docker, how you're going to communicate it, runs as root, and if anything's part of the Docker group, you can essentially become root on the host. So why is this important? Well, when you're hacking containers, this is like the hollow world to hacking containers. It's not new. And this is one of the first things that you look at. So where this came from is that there were a lot of instances where people wanted to use Docker within a container. Getting really Inception-like. Don't do this, by the way. There are better ways to do that, but that's where this came out. And this can allow you to do two things. A, it can allow you to break out of a container onto the host. Also, it can give you a local priv-esc. So you'll find in a lot of situations, especially in CI/CD environments, you'll be given your own EC2 instance or your own Google Cloud compute instance, and Docker.sock will be there because sometimes you run containers within that environment. But by default, you'll be running as a non-root user, and if you're not root, you don't have the keys to the kingdom. You can use this to break out and become root. And that's had some interesting consequences actually quite recently. So how do you pwn Docker.sock? So firstly, you've got to identify Docker.sock. You've got to interact with it. So depending if it's mounted on an interface or on a Unix domain socket, you need something that can speak specific datagrams for that. So either curl or the Docker client. There's a few other ways you can do that. Now once you interact with this, it's basically the API with Docker. And you can say create a new container or mount this interface. Everything that you can do with the Docker client is done via this sockets. What you then want to do is create a new container. And you want to mount the host's container, host file system in the container. And then you then want to run into this container, and then you want to chroot containers. No, chroot was going to come around sometime in this presentation. But you want to chroot the mount that you did in step 3 in your new host, and then basically it is like your root on the host with access to everything. Really simple, really easy, and a lot of fun. As you can see, there's a wash, rinse, repeat method over here. So there are some quirks when it comes to this kind of stuff in containers. Looking for sockets can get tricky because living off the land in containers, it's a lot of fun, but it might be the case that the useful commands that you need to find sockets might not be available. So for example, if you run good old Docker image, it's very limited. There's not a lot of commands, and that's not just the only container image that is like that. So find or ss or neset or whatever might not be in the container. So if you don't have these commands, literally one line of bash that you could normally do to find sockets are not there. Another issue that you have with this is that the socket might not be mounted at var run docker.sock. It might be mounted at BOtB. So now if you've got to traverse this entire file system and look for sockets, and if you don't have the commands that you normally use, this can get a little tricky. So how do we solve this? Well, syscalls, and this is where amma-contain comes into play. Just because the command or the binary isn't available doesn't mean that the syscalls that are required to do that aren't available. So on the left, those are the syscalls for a standard Ubuntu system that are required for the find command. On the right is some Go code to basically implement that. So the find command might not be installed in the container, but the syscalls might be available. And the really nice thing about Go, yes, that is very terrible Go code. Like I said, I'm not a dev. I break stuff. But you'll see that there's no shell commands being executed. And the great thing about Go is that it'll go and execute underlying syscalls, so you don't have to rely on shell commands, which is really neat. So same, but different. So how do we actually go ahead and do this? So show controls. And so what we have over here, so I'm on my host, on my Ubuntu host. And we're just going to watch that directory in temp. In the top, we're going to run into a container. And we can see we've mounted a socket at temp. This is not a socket. And we're just going to mount a local directory that has the binary in it. So once we go to BOtB, we're going to tell BOtB, always run BOB first, just to check that it actually can run on your system. And we're going to tell BOB, tell me what you can do. So there's a whole bunch of stuff. But first things that we're going to do is we're going to look for sockets. So it's going to look for Unix domain sockets, because there are other kinds of things you can do. And in this case, we find a socket at /temp. This is not a socket. Whoop-de-doo. What do we do now? We Google furiously on Hydroponic sockets. Now we say autopwn equals true. And now what Bob's going to go ahead and do, it's now identified the socket. And now it's going to check if it is a Docker socket. And if it is, it's now going to give you a shell in a container, which gives you a shell on the underlying host. So now we are on the underlying host's file system, and we're going to go into the Bob folder, and we're going to create a file. And at the bottom terminal, you'll see that the file that I'm going to create is now going to appear on the host's operating system. So once that decides to come, there you go. So now on the host operating system, we've now played with the operating system. And then you can exit with Bob. You were given an interactive TTY, and now we're back on the container that we were in. If we go back to temp, we won't see what we were there. So that is the hello world to breaking out of containers. It's been around for ages. You'd be surprised how common it is. There's a lot of security through obscurity by, hey, people are going to look for var run docker.sock. Let's mount it at blah, 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 blah. Because they'll never find it. Well, you can. So, in this case, Bob can be used to get a shell on the host. I think pentester, nothing, it says better in a report saying, oh, we got root on the underlying host and we could read, Etsy shadow. Sure. Engineers, how can they use this? They don't necessarily want to pop shells. So return codes are very interesting. So in your CI/CD environments, a shell doesn't really mean much, but you want something to say, hey, this is exploitable, this isn't. Bob will make use of that, and I'll show you that next. And then, of course, the last point, when you run the binaries Bob, it's got all the packages or utilities that you need. If the syscalls aren't available, that needs to do something, you'll get an error. I did leave a note to insert a Linux capabilities joke, but it wasn't there, and without being really cheesy, I think capsys make joke wasn't available. Awkward silence. Okay, that's cool. I had to do that at least once. So, how does this look like in an engineering environment? So we're going to do the same thing, but here we're using Heroku CI, so a normal CI technology, and we've now done a git push and a very informative error commit message. And now in our CI environment, we said run Bob autopwn, but CI/CD equals true. So what that means is that we're not going to drop into a TTY. We're going to tell Bob to set a exit code. Now, if you're familiar with CI/CD technologies and testing frameworks, if the exit codes are more than 0, it means something has happened. If it's 0, you get the thumbs up. And while this is running, so we'll get to the interesting stuff. So you can see here, Bob has run in this environment. Now, our staging environment and our CI/CD container environment is the same as production. We are using those assumptions. So whatever we're testing in staging should be the same as production. So, and as we can see over here, Bob found some sockets, but they were not able to exploit them because those are not Docker sockets. So the test will pass because we're not mounting docker.sock within our containers. And this is pretty much how Bob will work in a CI environment. The exit code was 0, the test passed. So in terms of docker.sock, if you don't need docker.sock in a container, don't mount it. There are better ways to do it via Dant and a few other technologies. But if you do need to, authentication is your friend. There are a few technologies that do this. So there are certificates. And of course, if you are using Unix domain sockets, there's inter-process communication authentication that can be done that is specific to Unix domain sockets. Really cool. And have a look at that. But there's a whole bunch of hardening resources there to do that. But there's more to containers than just pwning docker.sock. There's also environment variables. So I think Linux post exploitation, but especially in containers. So you've got good old env and path there. Environment variables just happens to be the secret management approach for a lot of container technologies. And there's also procfs is definitely your friend. Why? Because just because you may have cleared your environment doesn't mean that the environment has been cleared for specific processes on the system. Go ahead and do this. Look at proc or whatever PID and environ. You will sometimes see that there's stuff there that is not in your standard shell environment. So it's very good to look at that. Often some juicy stuff there. So yeah, Bob accesses both. So basically, OS environment will give you the key value pair, and then also it'll access proc and all the PIDs in the system. Now, this can get a little bit tricky in containers. Why? Well, because ephemerality is that's a sigh of frustration there. So by the time you've listed the contents of proc, and then gone ahead and attempted to read proc PID environment, that process might not exist anymore. So there's a saying about when something hits the fan, generally happens over there. And then, of course, there's just proc FS, which is just, virtual file systems just can make your life hell. I definitely have some hair loss due to that. So I'm wearing the hat. And that's pretty much in Go code. You can see that there's very little shell commands. I am executing actually a shell command. It is a bit of a hack there to verify the contents of proc PID because it can get a bit tricky that the file exists. There is actually a file descriptor for proc1 environment, but there's actually no contents in it. So that's where some of the weird magic comes in with proc FS. So, but we can go ahead and actually analyze the stuff. So how do we actually analyze it? Show controls. Make it full screen. So we're going to run a Docker container and we're going to add an environment variable. So touch of approval, super secret password. And we're going to run BOB. So BOB by default, so if you use the recon, very hacker, super cool option there, it'll go look in proc and you'll see it's found a whole bunch of processes that have that environment attached to it. So it's your shell at hand that you're actually in, or your bash environment. And it'll go ahead and actually look at env as well, because stuff might be hiding in both. And by default, Bob will look for secret and password. You can also go ahead and specify a word list, because it's 2019 and word lists are super cool. And in this case, we're going to tell Bob to look for, once I've reached that point, cool, yes, we're looking for YOLO, secret, find me, and Bob. And we're going to remove that, and we're going to tell Bob, just look for some word that will come up. Past Chris chose something. What did past Chris? Find me. Cool. So yeah, so we're going to look for find me in environment variables. And we should get nothing. And there we go. And if we look at the return code that will come out, it'll actually be 0 because Bob returned nothing. In the previous test, when we had all that output for super secret password, the return code would have been 1, which is what I'm going to show you now. And there you go. So that's super secret password being found, and the return code is 1. That's been a bit cut off, but that return code is 1 or 2. So there you can see from a pen test environment, you're on a host, you want to scrape that information, you can do it. If an engineer, you can drop it in your CI/CD environment, which is what we're going to do over here. So inside our CI/CD test, we've said run a script, and I'll show you what that script looks like in a bit. But we're going to run 2 tests. So we're going to call a script, and that script has a test for looking for pwning Unix sockets. And then there's a second test that's going to use a word list and search for any of those key terms inside our OS environment or in our proc environment. And that's going to be run on every pull or every pull request or every push on our repo. So I'm going to fast forward a bit because I've definitely made way too much content for today. And I probably won't get it in 30 minutes. But what we'll see now is once the test is running, we will get, and there we go. So the test has run. So the socket stuff that we ran previously, that was the first test. And now Bob has gone ahead and done an environmental variable test from the word list that we used, and nothing in proc environment or in os.env contains those keywords. So whip-de-doo, we're getting green messages all across. So in terms of environment variables, you'll see there that Bob didn't need the CI/CD flag because there's no TTY being returned. So Bob by default will set return codes on the flag that you're setting. So you don't have to say -CI/CD equals true. Like I mentioned, you can supply a word list, or by default it will look for password and secrets. And in terms of remediation, well, this is a tricky one. Secrets management is hard, and it's mostly turtles at the end of the day. If you're going to use env for secret stuff, threat model maybe, so you can know what you're dealing with. And sometimes it is quite useful to actually nonce your data. But be careful with it, because if you actually threat model that, you'll find that you'll be creating race conditions for yourself. So it's an interesting problem, secrets management in the cloud. But yeah, there's more. Time to get meta. It was a bit of a millennial reference, but that's all right. Clouds. Containers love living in clouds. Who would have known? And because of this, you can find your metadata services in containers. So good old 169.254, it's in AWS, it's in GCP, it's in Azure, it's in a whole bunch of other clouds. And this is really cool because networking is hard in containers. And when these endpoints and metadata services are exposed, depending on the platform, you can do a lot of cool shit. So for example, in that instance there, that curl command, if you are in a EC2 instance and if that specific instance has an IAM policy or role associated to that instance, you can access the credentials through the metadata service. Now there's a whole bunch of other stuff you can do depending on the platform, from mounting volumes to creating hosts. It depends on the platform, but it's definitely something that you want to look out for. But that's not the only kind of endpoint inside containers. There's good old API, so think control plane. So your Kubernetes control plane, generally running on 10.0.0.1 or whatnot, or any other endpoints. There's stuff to be had over there. And you never really know what's lurking, because a lot of the time containers just get access to it because, routing is hard. And IP tables, IP tables in a container. Depends how much you hate your life that you want to do that. Then of course there's good old EC2 Classic. And if you take a quote out of the documentation in EC2 Classic, EC2 instances run in a single flat network that you share with other customers. Shit you not. It is 2019 and that is still a thing. So depending on what you're doing, either what you are mounting on interfaces is exposed to everyone else and vice versa. So you kind of want to check that. And of course, if you go back to container quirks, the command that you want to do, so you're on a box, so you want to nmap, you want to do IP address show or ifconfig, tell me what I'm working with. Sometimes you don't have that in a container, so it gets a little bit hard. So of course, let's have some syscalls that will do that for us. So a really simple example with BOB is, this is a feature that I want to, definitely build out a lot more. But BOB by default will look for two metadata services, and we just say metadata equals true. So if you don't provide an endpoint list, BOB will look for 169.254 or kubernetes.default.svc, and you see there we got nothing. So now we're going to say, you know what? See if you can hit Heroku.com from the container. And we're going to provide an endpoint list. And what BOB does, and if it gets a valid HTTP response from any of those endpoints, it will change the return code and tell you that, okay, I got a response from Heroku.com and the response was a 200. Now, you see the response code has changed, and that can be quite useful in environments where you want to actually go ahead and test for these kinds of things. So, like I mentioned, there's endpoints, return codes, 254 is a default. And in terms of remediation, the stuff isn't that hard. It's just, your access control list. But understand what is there. Test your environments for metadata services, because it's, I don't think it's that obvious that when you're building stuff in the cloud, that these things are available. And then of course, routing is your friend and authentication. Like, we've been securing endpoints for quite a while. But if you don't know if your endpoints are there, you don't know what you've got to secure. So all of this recon stuff is fun, and there's a few other recon options, so getting interfaces, IP addresses, port scanning, all the fun post-exploit stuff. But especially with containers, there's binary hijacking, and this is if you really want to break some shit. So often there is the case that container binaries are executed by outside entities. For example, Docker exec, if a container is running and you want to list the contents in a container, you say Docker exec Docker ID ls, and you get the contents of that container. Cool, alright. Trust the command at all. Like, it does not check, am I actually running ls in the container? Sure, if it's your container, you're pwning yourself, but there are some weird edge cases that we'll look into. But also, kubectl copy, really cool vulnerability. I have 5 minutes. Cool. That is, I probably hit halfway, so I apologize for that. But we'll get into the binary hijacking quickly. So execute a container's tar binary, and look at this link. It's really, really, really cool. Basically owning Kubernetes control planes. So at some point, a container might be executed. So what do? We just hijack all the binaries. So yeah, you could break stuff in a container. But what I am going to jump to is, these are all in the slides, that's how you do it. In this case, we're putting containers. But this is what you can do with binary hijacking. It might be immediate, it might not be immediate. It might happen in 1 minute, it might happen a month later. I've seen a month later where containers of mine in certain systems have been archived, and what's happened is then the orchestrator has executed curl commands in my container and provided a token. And of course, I've then gotten that token. Of course, you can break systems. The command is expecting output A, you provide B, the system breaks itself, and then general balkage. And I've just gotten the red flag. Thank you for your time. The slides are available on the repo, and I'm going to stop talking before they throw me out. So thank you very much.